And his talk is Open Source Design Intervention Support Tool for Climate Resilience. Welcome on stage.
Thank you. Good evening to everyone. Thanks for staying until late. And today I'm going to present you our agroforestry intervention design tool, which is being developed as a part of a bigger project that aims to guide agroforestry interventions and to evaluate areas using the water, energy, food, and ecosystem nexus approach in arid and semi-arid areas across the greater Northern African region. This project is a 3 years long EU-funded project that aims to support African communities to adapt to climate change and to use their resources in a better way to make those areas more resilient. The partnership is involving many institutions mainly across Africa and Europe, and to evaluate the validity of the solution, 3 main living labs have been selected together with smaller sites around the Sahara area. Again, the project goal is to combine agroforestry interventions and data-driven analysis together into digital solutions that can support the improvement of these arid and semi-arid areas. Before getting an overview of the solution itself, it's maybe good to have an understanding of the context in which the software is being developed. And a big challenge that the project is facing is the very heterogeneous stakeholders landscape. And this digital solution has to take into account many different classes of stakeholders that can go to farmers with very diverse educational level that is not always very high, to decision makers and researchers that have very different technical backgrounds, expertise, and goals in the project. In addition to that, it's important to mention that this is a very large consortium with many partners. These are only the logos of the partners that are actually the work package leaders in this project, but many others are participating with different goals, responsibilities, and research topics. And a challenge that this software solution has to face is that all those research areas have to merge inside a single tool and solution that will be then used to perform the analysis. Another main challenge of the project is the very sparse and fragmented data, because in those areas it's not always possible to rely on well-established and consistent data collection systems. And for this reason, the data required from the model to be run is not always present. In addition to that, on top of that, we have to take into account that the solution is using living labs and smaller sites as a test bed to evaluate the solution, but the software itself has to be developed to be more scalable to larger areas and also to be adaptable to other study cases. So how can our solution support the research in this context? Well, our goal is to ensure the fairness of the data collected and produced by the project, and also to make an inclusive and accessible solution to enable data-driven research and analysis in this context. To do that, a data management system is being developed to support the collection, pre-processing, and storage of the data for the entire project. And in addition to that, this decision-making support tool is being developed as an interface between the decision makers and analysts and the models that are being used to perform the different analyses involved in the project. Regarding the data management system, it's also important to mention that our center is collaborating in the design of low-budget, made-in-Africa sensors that will serve to fill the data gaps and provide us the data that is actually still missing and is needed from the model to be run. Considering the very distributed and large amount of different data sources that this project is having, another focus of our data management system is also the data integration layer that will be used to orchestrate these different data sources and prepare the data to be ready to be used by the models and the tool itself. To ensure the fairness of the data, also the environmental data platform of URAC will be used to create and manage all the metadata linked to the data of the project. Jumping now to the tool itself and the concrete design of the tool, which is still a concept. This project is only at the end of the first year out of 3 years of life cycle of the project. So it's only still a concept. And here it's important to mention that our approach is a usability-first approach. And the reason behind this is that in the actual state of the art and in the different solution of similar project, usability is often taken into account only as a secondary aspect or not even taken into account. And this brings to solutions that are often very complicated. Sometimes they are relying on multiple components that have to be run separately to run a single analysis. And those solutions and applications are often very hard to use for the researchers that are not directly participating into the project, or from decision makers and researchers that have a very high and specific level of expertise in this field. The aim of this project is to create a tool that can be accessible and usable for an average decision maker without very technical and specific expertise. And to do that, we are involving the different classes of stakeholders already in the early stage of the design of the tool. In addition to that, to make this solution more accessible, we decided to create it as a fully web-based solution to decrease the installation barriers and making it more easy to access and to configure. Again, one of the issues that similar solution we are having is that they were relying on multiple components. This tool is also aiming to connect, to be the single entry point to access all the data, models, and different tools that are created within the project and will be used for the analysis. Also considering the very heterogeneous stakeholder landscape, the tool has also the need to have the functionality to generate multi-level reports where the data will be visualized and showed differently based on the stakeholder targets of those reports. Here is a very simplified user flow showing the process that the user will have using the tool. The user will be able to access the living lab information and visualize all the data, the actual state of the current actual state of the living lab, the data source connected to it. And this tool will also support the user to eventually configure a new living lab and connect the new data sources to it. After that, the user will be able to select the different models that will be chained and connected to perform the analysis and set all the necessary parameters to perform the analysis. And after that, the models will run in the backend in case multiple models are combined into the same analysis. From the outside, this will look as a single model will be run, and all all the necessary steps to link those models will happen in the background into the backend. After this, the user will be able to visualize the results and eventually generate these multi-level reports I was mentioning before. To conclude the presentation, I will just go quickly through the ethical consideration that we are taking into account when designing this app, which are, again, the usability first approach with the aim to make this solution accessible for a larger range of users and decision makers. But also to consider low-code solutions, especially for some components, like, for example, the data integration layers, where we are considering different technologies that can maybe give the possibility to the researcher to create by themselves their data pipeline and extend or modify the data source stack without relying necessarily on software developers. This solution will be created as a microservice architecture, and this is to simplify our work because many partners are working on different aspects with different methodologies, programming languages, and frameworks, and this will reduce the integration aspect at the end of the project. But this is also enabling eventually some partners to still keep the ownership of some components without affecting us to share all the rest of the solution as an open source solution, which is our goal. And we'll also make it easier to eventually extend or modify this solution and adapt it to similar projects in the future. As I already mentioned before, also the web-based approach is a decision that we are taking to make this solution more accessible and usable for everyone. So thank you very much for the attention. I'm done with the presentation, and I'm here to answer to all the questions that you have. Thank you very much.
Very much, Michele. We have 2 minutes, and so we have time for a question or two. Are there any questions? Yes.
Thank you, that was interesting. Do you plan to have any standardization activities in the project? Like try to contribute to standards, because sometimes in the European project there is like a work package or some task devoted to standardization.
Well, there is no specific work package focusing on that. Please correct me if I'm wrong, but of course we are like the data types we are using will be very different in the whole project, and our goal is to follow different the standards that we can follow as much as possible, like, for example, the OGC standards, to also to ensure to make it easy to reuse the data and access it, and to ensure the fairness, basically, of the data produced and collected within the project.
Okay, thank you.
Okay, thank you very much. An applause to you.